All right, we have arrived to section 6.5, logarithm properties. The product rule for logarithms. The product rule of logarithms can be used to simplify logarithms of products by rewriting them as the sum of individual logarithms. So when we first introduced logarithms, I kind of mentioned this. It is derived from the exponential properties. And all of this is for a base being greater than 0. So again, we're looking at those positive values for those bases. All right, so let's take a look at this and test it out. All right, so we want to expand, so we want to make it larger. Logarithm in the 3, 10x times 3x plus 7. Okay, so let's start off here. We're going to basically break it apart, all the multiplication pieces. So here's log base 3, 10, 3x, there you go, plus 7. So one thing for us to notice here is that there is multiplication that is happening here and here. Okay, so we want to break that up. So we're going to go ahead and do log base 3. Here's our first one, 10x, plus, we're breaking up this multiplication here, log base 3 of 3x plus 7. Okay, so now we have to ask ourselves, is there any more multiplication that can be broken up? Well, we can break here, because remember, this is just saying 10 times x. But here, this is saying 3 times x plus 7. So because of this plus 7 here, we can't break this up any further. So this entire side is done. So let's go ahead and break this one up, and we're going to break it up here. So it's going to be multiplication here. So that means that this side will turn into log base 3 of 10 plus log of x, I'm going to drop the 3, base 3, plus log base 3 of 3x plus 7. Okay, and so that's it. So now we've expanded this as much as possible. So in this particular example, I'm going to go ahead and pause it, and I'm going to see if you can condense it. So now you are going backwards. You are condensing it, so you're trying to make it smaller and not larger. So take a moment and try that. All right, since we are condensing, we want to notice that addition sign there, and also notice that the bases are the same. We have 4, so that means we can in fact condense them. And so we're going to have 3t times 5w, and we're going to go ahead and multiply the 3 and the 5, so we get 15tw. So this would be the condensed version here. All right, let's take a look at the quotient rule for logarithms. The quotient rule for logarithms can be used to simplify logarithms, or a quotient rewriting the difference of the individual logarithms. Again, here is where I want you to pay attention, because it is the difference or the division, sorry, the quotient of the input, m over n. It's the quotient of the input, not the quotient of two separate logarithms. So let's go ahead. We're going to expand this one. So notice that our quotient is here. So we're going to expand it and turn it into a difference, right? So we're going to start off with log base 9 of our numerator, 5y minus 7. And then we are going to subtract log base 9 of our denominator, 2y. Okay. Now, because we are attempting to expand this, our goal is to expand this as much as possible. So notice that because this is a 2y here, this is the product rule, the one that we just looked at. So since this is the product rule, we can expand this further. So we would end up with log base 9 of 5y minus 7 minus log base 9 of 2. And let's go ahead and share we're encompassing all of the denominator. So base 2 plus log base 9 of y. Okay. We can decide to clean this up a little bit by distributing this negative to both of these logarithmic functions, and we end up with log base 9, 5y minus 7. We can't expand this term because it has that subtraction. It's not just multiplication. Minus log base 9 of 2 minus log base 9 of y. And this would be our final solution in totally expanded form. All right, example 2 has us working backwards. We're going to condense it. Go ahead and try this one out. Condense it. All right, so looking at this here, we can see that the condensed version, and we can in fact condense it because we do have a difference quotient here with the same base 3. And so we put 14x over 2. And in reducing that quotient, we end up with that the completely condensed version is going to be log base 3 of 7x. Okay. All right. So let's look at the power rule of logarithms. So now for the power rule, we're going to be simplifying the logarithms of a power by rewriting it as a product of exponents times the logarithmic base. So for our power rule, notice that we can take the power and we're basically pulling it outward. Okay. So when we expand this first one, our power of our input is 5. We're going to pull that to the front. And so that's just going to become 5 times log base 2 of x. So if we want to rewrite 4 times ln of x to have a leading coefficient of 1, this is basically telling us we want to get rid of this 4 here. So if I have 4 ln of x, we're basically using the power rule in reverse, and we're bringing this back in. So it's going to be ln of x to the 4th power. Okay. All right, so now we've kind of arrived to one of my favorite parts here with logarithms, and it's kind of combining all of these things together. So let's take a look here at this example. Using the logarithmic properties we have discussed, expand the following. So we're trying to make these large. I'm going to have you try B on your own, but let's do A together. So we're going to start off. Notice that I have a quotient here, so I'm going to start with the quotient. So I'm going to have log of 6, and I'm going to have 6x minus log base 6 of y. But so the next question you want to ask is, am I done? Is this as expanded as I can? And notice that we do have the product rule there, so we can expand this a little bit further and say log base 6 of 6 plus log of x minus, I dropped the base 6, log base 6 of y. So this would be as expanded as I can get, but I am able to reduce something, because what is log base 6 evaluated with 6, right? So this is telling me that the base 6 to some power equals 6. Well, we know that that equals 1. So now that we have expanded it as much as we can also simplify, and we can use some of those properties to help us simplify. So this would be our final answer. All right, give the second one a try. All right, class, this is what you got. So go ahead and take a moment to think about it. So notice we're going to start off by expanding using that quotient rule. And the first thing we notice is that here in this first one, we actually have our power rule. So we can expand this further. And so we go ahead and expand it further. And then notice that, sorry, here, this is not a power rule. This is our product rule. I used the wrong P word. Here we have the power rule that we can use. And so we can bring both of these to the leading front. And so our final answer is 4 times ln x plus 3 ln y minus ln of x plus 3. All right, for C and D, we have the opportunity to expand them some more. Go ahead and take a moment. We're going to focus on C first, and go ahead and expand that as best you can. All right, so we're going to start off, and notice we do have a product of 2 3/4 and x to the 7th of 2 different terms. So we can break that up into ln of 3/4 plus ln of x to the 7th. And then here we do have that power rule that we can apply to bring that 7 to the front. So you should have ended up with ln of 3/4 plus 7 ln x. Okay. All right, go ahead and try D. All right, so for D, I think the trickiest part here is to remember that when we take the square root of a value, it is the same thing as raising it to the 1/2 power. So the square root of 5x is the same thing as saying 5x to the 1/2 power, which in this case tells us that we have the power rule here that we can bring to the front. So that's how we end up with the 1/2 log x. And then here, now we can take care of what's inside and realize that this is our product rule. Okay, and so we can break that by addition of our inner terms. So here it is important that the moment that we did the product after the power, that we are kind of encompassing that we're breaking this up, but that 1/2 is being multiplied to everything. So that's why I use brackets here. And so now we're going to distribute that 1/2 to every term, and we get our final answer to be 1/2 log 5 plus 1/2 log x. All right, we're going to take a moment now to look at this going backwards, and we're going to condense the following. So now we're trying to make it as small as possible. So let's start here. Notice that I'm adding two values here, and since I'm adding, this means that it's going to turn into multiplication. So this is going to be log of 3 of 5 times 8 minus log of 3 evaluated at 2. So now because I'm subtracting, this is going to be a quotient. So this becomes log base 3 of 5 times 8. I haven't multiplied anything out yet, and I'm going to divide this whole thing by 2. Okay. So now I can go ahead and apply this off. 5 times 8, that gives me 40 divided by 2. That's going to be 20. So this final answer is going to be log base 3 of 20. So that's really nice because it just kind of collapses all the way down there. All right, go ahead and try number 2 on your own. All right, so for this one, we're going to start off looking at the fact that we have a couple of different power rules here. So notice I applied them and I went ahead and brought up the exponents there. The 2 is going to be applied to the entire 3h, not just the h, so it's going to be this entire thing squared. So now notice that we do have the sum here, so because we have addition, that turns into the product rule going backwards, and so we're left with w cubed times 5, h to the 5th power. And so now I went ahead and applied that square, so I got 9h squared. And so now we are going to take care of that subtraction and turn it into a quotient. And so we're left with w cubed times h to the 5th all over 9h squared. So here I can reduce the h to the 5th and the h squared. We're going to end up subtracting those exponents, and so we end up with a final answer of ln w cubed h cubed all over 9. All right, let's take a look at the change of base formula. So the change of base formula tells us that we can be used to evaluate logarithms with any base for any positive real number m, b, and n cannot equal 1 and b cannot equal 1. We have that the log b of m can be broken down, so any base we want, any b, we can break this up by taking the log of n, our new base, of our original input m, and divide that with the log of n of our new base, but now the input is going to be our old base. So it follows that the change of base formula can be used to rewrite logarithms in any base as a quotient of the common or natural logs. So I can take log base b of n and rewrite it as the natural logs or as the common logs to be able to easily input them into my calculator. Okay. Nowadays we have very fancy calculators and we don't necessarily have to do the change of base anymore. So I'll show it to you, but it's fine for you to use your calculators to evaluate the logarithms without the change of base. So the way that we deal with this, so we want to change this particular log base, why is this not writing? Log base 5 of 3 to a quotient of a natural base. So remember the natural logarithm, this is our ln n. So we're going to take the original, so log base 5 of 3, and this is going to equal, now I'm going to take my new base, ln of 3, my original input is going to be divided by ln of my old base, which is 5. Okay. All right, so now you can go ahead and plug in ln of 3 over ln of 5 on your calculator, and you're going to see that you're going to get 0.682. Okay, 6. So one thing I want to mention, because remembering the change of base, sometimes, you know, you try to remember which one goes on the top, which one goes on the bottom. So usually when I do this, I always try to tell myself like this, right? I draw a slanted line telling me that this is going to be on the bottom of that denominator and that this one is going to be on the top. So if that helps, great. If it doesn't, then forget I showed you. But that just to remember that that 3 actually goes on the bottom, and that 5 goes on the, the 3 goes on the top and the 5 goes on the bottom when we're doing that change of base. All right, evaluate the following, and we want to round to 4 decimal places. So take a moment and find those 2 values. You can do the change of base and make sure you got it. All right, so now I went ahead and just evaluated it as if I was using the change of base formula. So again, remember that log, I've changed it to the common log here, so log 10 over log 2. So again, remembering that the input is what goes on the top, and then the base goes on the bottom. Same over here, so I have log of 10,000 over log of 8, and I went ahead and found those values here. Okay. And that actually concludes our section 6.5. Our next section, 6.6, we're going to be talking about exponential and logarithmic equations, but that's in our next video.